All right, everyone got a drink, got a seat again. Next talk from Stijn, familiar face. I think you've given 4, 3, 4, maybe 5 talks.
One big one.
One big one, but you've been at the meetups quite often indeed, so good to see you as well. Again, interesting topic. I think a lot of people are looking at this as well. The funny talk from Robert, he left maybe already, also highlights how important it is to keep investigating and don't sit still. We're not losing our job to AI, we're losing our jobs to the people who are using it if you're not using it yourself. So very important topic. Really excited to see what you're talking about. Thanks.
Thanks. Do you hear me? Yes, great. Okay, so in short, I'm Stijn. I work at A.C.A group. I've been a mobile developer for like 8 years. I think 4 years Flutter, 4 years Xamarin Native in a very distant past. And I'll give a talk about architecture, application architecture in an AI-assisted world. We have a lot of code generation, very cool, but it's maintainability, scalability, everything like that. You get chaos very quickly if we don't keep it in check. Very large disclaimer. It's of course a highly opinionated talk because there's no right way to do it, but it's my idea on how we can keep it a little bit in check and the things you can do about it. The problem, AI, very powerful. You ask it a question and it writes code, a lot of code, and suddenly you're in a big mess, a lot of technical debt. You have no clue how to get out of it. You ask it the question, hey, can you create me a new login view? It's easy. You have my application, my coding assistant will help me, and then it writes code. Great, it uses block. I don't use block, we use stacked. It's not in my code base. We use MVVM, please use it. It's a lot of crap. They got a lot better at that. They'll check what you have, but still, often you get wrong patterns inside your code base. It goes through a very long session, it generates code, and suddenly says, oh, I don't need this anymore. I just don't reference it anymore. It just stays in your code base. You have methods that are no longer used. It likes to return widgets a lot of the time with build methods. You get some magic values somewhere. I rather have my translations somewhere, not directly in my code base. But it just says code generated successfully. Here you go. You have a login view. It runs. You look at it. Oh, it works. Of course, good developers as we are, we create a PR. You don't have warnings or anything enabled, and you just say, oh, the code looks good, I think it's fine, you miss stuff, and you just merge it away. And glad as we are, your technical depth went up again, and just your chaos will win in the end. It starts with a lot of small things, but it will just add up very quickly, and the problem with AI is that it goes very, very, very quickly if you don't put your guardrails up. Because it's very easy to miss stuff even in code reviews. So in my opinion, where do you need to start before even using AI? Step 1 is define what your application architecture is. For me, there's no right architecture. It is just at least have one, have an idea on how your team works, what works for you, have a way of enforcing it. It's great to have documentation, but if you can enforce it in code, if it's visible in code, it makes it a lot easier to enforce. You don't forget it. It's not some afterthought during code review, hey, this is bad, but yeah, this feature needs to go to production, so just merge it anyway because everything needs to go fast. For us, it's some naming conventions like we have P0, P1, P2 because we have different layers, but it makes it visible. Things are structured in a specific pattern. so it's easy to notice. We also switched from a folder structure to having projects, just because we can enforce it with your pub/spec and YAMLs what the dependencies are, so things cannot be imported or moved to the wrong project and suddenly have dependencies it shouldn't have. And it's actually just make it as simple as possible. How does it look for us? We have a layered architecture, or a derivative of clean architecture, where we just have different layers, where we have a specific flow. We never skip layers. It's numbered. Each layer is a project. Where we have a presentation layer and the UI, application layer, data layers, domain layer, and a lot of shared foundations. What they exactly are isn't that important. In the UI layer, we have our MVVM, we use stacked. It's just our presentation logic, where our view is purely UI. It delegates to the view model and delegates back to the view model service for more the creating of your objects. In the second part, we have our application layer, which more orchestrates things like, fetch data from your API, store it in your persistence, cache the data. We also block it that we never throw exceptions past the application layer. We work with response objects, so we know when we get a response back that either you need to handle the success state and the failed state, just to make it easier and not have try catches everywhere. But that's just what works for us. The data layers, we have rules. DTOs never leave the data layer because we had that in a very distant past, and it just creates problems. We also always map to a domain layer. It makes it quite easy. You know where your bugs are if you need to find some things. Same with persistence, similar pattern. In our domain layer, it's purely Dart. It's mapping of some things, domain-specific validation and calculations. And then as a last part, we have some shared foundations where our dependency injection lives, our translations, design system. These layers do not have dependencies on other layers, so it really goes P0 has no dependencies on other projects, P1, P2, P3. The data flows down. You can have a completely different architecture. This will work as well for everyone. We have a very clear understanding with everyone how it works, and makes it quite easy for you. This is a bit of an overview on how the data flow goes, where user taps on a button, the command goes via the view model to the view model service. This delegates the action to the application service, which says, oh, I need to do an API call. I'll do the API call. Goes to the API layer. The API layer gets a DTO back once it does an API call, maps it to a domain layer. The response comes back through the application layer. This is then communicated to the view model service, which updates the state, and this updates our view in the end. Nothing more than that. So as our first foundation, just have your architecture. There comes the second part. You also have more than that, have coding guidelines. For us, it's just nitpicking, picking a few things that are there. It's like naming conventions. For us, an interface starts with an I, enum start with E, DTOs end with DTO, entities end with entity, which makes it very easy for us in code review to know intent, and if you use it, to work with it. Complexity limits, we have a certain amount of lines. We allow for a function, maximum amount of nested ifs. If there needs to be a new white line before return or not, it just creates consistency throughout our code base, which you get trained in it, and it makes it easier to spot, oh, there's something wrong there. Completeness, we enforce that switch statements handle all cases, just so you know if you add a new case, your compiler will complain, and then you'll never have bugs because you forgot it at some point. Error handling, as I said before, our application never throws exceptions and works with a response pattern. Having all these rules there makes it quite obvious when you go out of bounds in the code, and we also enforce it using linters, so it's easier for everyone to maintain, and your code review goes a lot faster then. We had some common violations in the past, having the layer skipping. That's why we introduced the projects, so we can enforce it. You cannot import things that you cannot see. We work with barrel files, so we also have things with if you import things directly from the source, you get exceptions there. The exception handling, same thing. We learned it along the way. Now everyone just does it, so it's never an issue anymore. Naming conventions, it's created a lot more consistency having them enforced. Reactive values, it's just everyone learning also the patterns that are there. Then those first two things are very nice and very easy to have. You agree upon how does our application look like, and then it starts, I want to create a new project, what now? There are different ways to do it. You can have a repository which you clone every time and change the names. If it works for you, it's nice. Just make it yourself as easy as possible. If you want to enforce an architecture and want to enforce coding guidelines, have a way to have a quick setup that you don't have to copy paste everything manually because you'll forget things. For us, we use Mason for that. We use Mason for our Flutter setup, where we have more complex things like we run Flutter create beforehand to create all the different projects. Then we copy paste, let it copy paste in our template, and then finally it will start adding all the dependencies also via command line, just so we also always have the latest versions. Sometimes this creates dependency hell. Most of the times it goes well. We do not only use this for our Flutter setup, we also use this for common patterns we have. If you need to have the same boilerplate code every time, you can choose to go to a build runner for code generation. But for example, for us, Mason works very well. Our view needs to be at a certain position in a certain directory, or view model at another position, other directory. There's an interface, there's the view model service. It's the same boilerplate code every time. It's a lot of code. If I need to create a new view by copy pasting it, it takes like 5 or 10 minutes. If I do it this way, it takes 10, 15 seconds. Mason make view model and done. Same for services, same for, we have models for example, because our DTOs are mapped to the main models, most of the time they are the same. So make it easy for you and just let it automatically create everything from us, from the backend, from the server pod, completely until the front end. We have an easy way to create mappers and everything like that, just using Mason. Just create no AI there, just boilerplate code that's automatically generated. How does it look like? Here, Mason make view model. I give in a few parameters, and done. Of course, it went faster than it goes in real life, but that's about it. It makes your life a lot easier. Next step, the static code analysis. Use your linters. We use the standard Flutter analyze, but we also use custom lint. For us, there's things like we enforce the maximum amount of lines per file, just because we know if you go over that, probably you're doing too much. You can ignore it if it needs to be there, but then at least it's your active decision to do it, that we do not have 3,000 lines of code in a file. Same for functions. We play around with it a little bit, but that's what works for us. The exact rules is also just depending on what your coding guidelines are, but it makes your life a lot easier. We go for 0 warnings. If there's a warning, the CI will pick it up and the CI will say, no, the build doesn't go through. And it just prevents bad code or code we deem to be bad to be merged in. And will also help you later on. If your AI generates code, it's never going to be merged in because the CI will block it off. The first 15 lines of our custom of our rules. Unit tests, same. If they're there, you can at least prevent refactoring from breaking things. And if AI likes to refactor a lot of things, at least you can run it beforehand. You can tell the AI to run it beforehand, but it will make your life easier instead of harder. As we went before that, for us, we use Bitbucket. We have specific rules where we require an amount of succeeded builds. The succeeded builds contain the unit tests and contain the linter rules that they are checked. So if those do not pass, you cannot merge it. Same, someone needs to review your code. Doesn't matter if you change one line of code. Doesn't matter. Someone needs to accept it, else it's not merged. It's easy to think, oh, I just bypassed this and I merge it, and then suddenly your if check of one line breaks your complete production application, and no one ever tested it. And the same goes even if it's human or AI, same rules. And the last part before really stepping over to the AI part is having documentation. With all the previous things, we have things on Confluence or your wiki, or if you do it in Notion, doesn't matter. But if your AI does not have access to your documentation, it can never use it, and it will do what it thinks is best, and that's the crap it's trained on. So that's not always good. For us, we have 3 tiers. We have certain golden rules who it can never. They're always on. In this case, it's for Windsurf. But it's things it really should know. We have our layered structure, or things it does wrong constantly. For example, we used Stacked. It kept on using the old version of Stacked. Just tell it, ensure that it's a limited set, but it's always on. Then we have second tier, where there's a lot more documentation, where it's I don't know how many lines of code. Documentation it is, but a few thousand for different layers, how every layer works, how our unit tests are written, where your design system is, examples and everything like that. But they are all structured for us in different markdown files, which are referenced starting from the tier 1. So it only reads it when it needs it. And the last part is the workflows. Those are your agents or your commands or skills, depending on what framework you're using, which I will go over in a little bit. But those are also quite important to make your life a lot easier. Each tier just builds upon the previous one. You have references to everything, so it knows what to use and does not need to find it throughout your code base without a reference. And the AI reads it, so also prevents it, because if you need to correct it afterwards, if it went down in a rabbit hole, just revert. It's difficult to, if it goes very badly, to get it out, because your context is bad at that point, and will still make the same mistakes over and over again. Also, concrete examples work a lot better than telling it, oh, please do not do this. If you show it some things, it's a lot better than trying to explain it. The golden rules. I think I need to zoom in a bit. For example, the layering I talked about, application that never throws exceptions. Just few basic important concepts that are important for us. In the second tier, where our reactive value needs to live, most of the time it gets it right, so I don't care. it's in a lower tier. The workflows, it just, these are very syntax, but it's just a step-by-step plan, as in you'll need to understand the requirements, explore the code base, design the plan, and then create an implementation plan. It goes a lot deeper than that, but it makes it more structured in the way it goes. It will become more clear in the next slides, because that's what this is about. The AI agents or the workflows. For us, I think for me the biggest leap in our code quality that's generated if you go to the agentic way of working, because if you work within the context of one file, it's fine, it doesn't hallucinate that much. But if you start, hey, implement me this feature, or even if it's a smaller part of the feature, it can go bad very quickly. It starts going one way, and then suddenly it starts duplicating code everywhere, and it just revert everything, and I'll write it myself. Introducing the concept of specific agents for specific tasks increase the code quality a lot. It just makes them more specialized. The first version I made were just 10 lines of me telling it, hey, you're an architect, create a plan. The coder, hey, implement the plan. And even that already jumped up quite a lot. Now they're a lot more complex. The first part is the architect. It's actually just reading the user story or reading your request and start planning. Try to understand it. Try to know which layers in our code base need to be affected, what files need to be read, and I'll document everything in PlanMD or document them just in a file and create a step-by-step task list, which we can mark off later if things are done. This makes it easy for you to review what's the plan even before it starts coding. And then you introduce the coding agent, and that's just, hey, read this plan someone else created, and mark if you've done a step, stop. Then I can review everything, and also mark this step as done. Check the definition of done. Check the acceptance criteria. Check if it runs. Run the build runner. Everything that it needs to do. And you then can continue. Those things are actually the main part of writing your code. I had some issues with the unit tests, so I created a different agent for that. It makes it a lot easier just to have it one task. Hey, check this file or check the last commit and create extra unit tests for this, or this failed, create something for that. We do it this way. We use Mocktail, or these are dependency injections. So things that it fails on makes it easier to have a specific task. We create a reviewer agent. Hey, nice, that code's written. It works for our own code. It works for other code, where we can focus more on what are our coding guidelines, where are they, review the different things. I gave it a limit of 15 comments tops, because normally that should be more than enough, and give it priorities, things that are critical or not, and it spots mistakes I would have never seen. Things like you copy two objects to each other and you missed one of the properties. I would never see that in a code review, and it makes it also very easy for you. You can let your coder agent, once it's done, as a definition of done is the reviewer should approve your code. It should say it's okay to merge, else just continue or create a new plan, whatever you like. We also have some constraints. Our architect can't code. It can write a markdown file and that's it. Our coder can't skip steps. If it doesn't understand, it needs to stop and ask clarification. and just gives you a bit of discipline for your AI. How does the workflow look like? I think I talked about everything. You have your architect who reads the user story, creates the plan MD, the coder reads the plan MD and implements step 1. You, as a developer, still review the code, and you also review the plan MD, and just say, okay, you can continue or not, or you adjust some things. You write your tests. You can, before even I let my code review by Brent or something like that, I let my AI reviewer already fix a lot of things for me, because it will create a very, your flow will be a lot faster. And we no longer have runaway code generation. Also, these workflows use everything we built from step 1 to step 7. It reads out our warnings. There should be no warnings, so it prevents it from keeping on building on bad code. This is an example of how it runs. /architect, I gave it some database exception. I trusted enough to say run the code workflow directly afterwards. It just grabs from my code base and looks like, oh, I know that database who had an issue. It creates a complete plan. It creates different tasks that need to complete, and the coder workflow does that for you to fix, in this case, the deduplication logic. So yeah, the AI code reviewer, I already talked about this. It does what it does. It reviews your code from critical to suggestion. You can improve your AI by doing a lot of things. We build a lot of tooling beforehand, or for example, we created all the Mason templates. It would be nice that our AI just can use it instead of trying to create a view by itself. It's not allowed. It cannot do it. I gave it access to our Mason using an MCP server I built using Dart, which I had a talk about last time or the time before that. It's quite easy. It just accesses our CLI tooling and runs it, but it prevents it from writing bad code for us. It just makes it easier that you provided the tooling you created, that it also has this. Also, you can give it access to Dart. If you use the latest Dart version, you can add Dart as the MCP server, so it can read out everything from your analyzer as well, and run your tests, as it makes your life a lot easier. Of course, improve. If it goes bad, learn from it. Don't only fix the issue at that point, but also try to find what the cause was and let the AI itself update the documentation, just that you prevent it in the future. If you can add it to your linter rules or something like that, even better. But most of the time, don't forget that you can use your AI to update your AI to make your life a lot easier. The recap, we have a foundation which you need to build, no matter if you use AI or not. It's ensure that you know how you want to build stuff, make it easy to scaffold things, build your quality gates where you have your pull requests, your static code analysis, your unit tests. And if you want to integrate your AI, ensure that your AI has the right documentation and the right tooling to be able to work as a developer that works in your team. Your team has those tools, ensure that it has it as well, so it can make your life a lot easier. The key takeaways, I mentioned every one of them, of course. Just structure that enforces your architecture, helps you a lot of things. Automated quality gates, document also for your AI. And if you can create a guardrail for your AI that it cannot bypass, like the code cannot be merged if it doesn't pass your tests, then it makes your life a lot easier. Yeah, thank you. That's about everything. Any questions, anyone, or?